In each of the problems on page 9, we're going to practice applying these different twists on the second fundamental theorem. Just to summarize so far, we've learned two different tricky situations or twists on the second fundamental theorem that we want to make sure we're aware of. On page 8, you'll remind yourself of what those twists were. The first twist that we saw was the twist with the negative, where if the limit the unknown limit is at the bottom of the integral, not the top, then we have to switch the limits and put a negative in the front. That's one twist we have to be aware of. And the second twist that we have to be aware of is that of the chain rule. That if the limit at the top has anything other than just x, specifically if its derivative is anything other than 1, we have to multiply by that derivative in order to take the fundamental theorem shortcut that we want to so desperately rely on. So in question number 6, at the top of page 9, these are going to be some more chain rule examples. I'll just give you a heads up that the chain rule is all about question number 6, or question number 6 is all about the chain rule, I should say, where question number 7 is where both of those tricky situations intermix. So in question number 7, you'll see some chain rule questions, like letter C. You'll see some questions where the limits are switched, like letter F, and they'll be kind of mixed together. So question number 7 is really where we're going to tie it all together. Question number 6 is kind of exclusively just practice with the chain rule. Because of those two tricky situations, I personally think the chain rule one is a little bit harder. That's the one where I have to really train myself to do a little bit more thinking, and that's why I want to make some dedicated practice time just for that chain rule before we put it together with the other tricky situation. Now in question number 6, I'm just going to do a couple of examples, figuring that you can do quite a few of them on your own once you have a better handle of that on that shortcut. Don't forget to peek back at the notes that we took on the bottom of page 7 to remind yourself of the steps that we're going to follow. We're going to cancel the derivative in the integral symbol. We're going to rewrite the original function just with our dummy variable swapped out and our new upper limit plugged in. And then we're going to multiply by the derivative of the upper limit. That's our chain rule step. So let's think about those 3 steps in the context of letter A. We know it's going to be one of these problems because it says in the instructions to use the second fundamental theorem to find the derivative. So technically, even though the derivative isn't part of the original question A, I know I'm going to be taking the derivative of this problem, which means I am actually taking the derivative of the integral. You can write the derivative just in notation there, but we know that the derivative is going to end up canceling out. So that's something that you can go through the motions of doing if you want, but if you feel like you don't need it, that's okay. So remember, first step is that the derivative and the integral symbols are going to cancel each other out. So step 1, cancel the derivative elements and the integral elements. So that includes the dt. Those are going to cancel. And then recopy, now I'm into the second step, recopy the original inner function just with the dummy variable swapped out. I like to put parentheses when I recopy to show my brain where that dummy variable is disappearing from and what I need to show instead. We know that in essence we're making a basic substitution. The dummy variable t is going to get replaced with the sine x, the upper limit. So that substitution is actually really important, and that's what I want to make sure that I see. So I'm going to color code it just so I can tell that that dummy variable is out, whoops, and that the new sine x is in. So again, just to make sure that we can see it there, there's that little yellow. That's me replacing what used to be a t with the new upper limit sine x. Now I've done step 1 and step 2 in my steps that I wrote down. I canceled the derivative in the integral. I rewrote the original function just with the dummy variable replaced. And now step 3, I need to multiply by the derivative of that upper limit, the derivative of the inner function that I just plugged in. The derivative of the inner function I just plugged in is cos x, because that is the derivative of sine x. So that must be my answer. Now there's no real way to clean up this answer, of course, because sine and cos don't really multiply. So if anything, you could clean it up by just eliminating some parentheses or making the size of your numbers look a little bit more cohesive, but that's not a required step. That's pretty straightforward. And that means that our answer is 3 sine x cos x. It is deceiving when you do these second fundamental theorem chain rule problems that it doesn't quite look as surprisingly obvious as the original questions we were doing on page 7. Usually when you look at your answer on page 7, you would say, looks just like the original problem. I knew that was happening. That was easy. These aren't quite as obvious because 3t doesn't have a whole lot of visual in common with 3 sine x cos x, but hopefully you can see where each of those individual elements came from. The sine x essentially drops down into the problem. There's your 3 sine x. And then we multiply chain rule by its derivative, cos x. So that's going to keep happening. That's going to happen with all of these problems, and I'll do a few more examples just so you can kind of see that effect. Let's try one that doesn't have some trigonometry in it. Let's try letter C so that we can get a sense of what to do in other function examples. Again, same 3 steps. Cancel the derivative in the integral, rewrite the original function, just plug in the dummy variable, and then multiply by the upper limit. So I'm going to do the same thing I did before. I'm going to, just for symbology, write the derivative so that way I know why I'm doing this. I'm taking the derivative of an integral, which means to go through the motions, I am canceling the derivative with the integral stuff. That means what I'm left with is 2, but I don't have t anymore. Instead, that dummy variable is going to get replaced with the upper function, or the upper limit. The upper limit was square root x. So there's my replacement. Step 1, I canceled the derivative of the integral. Step 2, I rewrote the original function just with the dummy variable swapped out. And then I'm going to multiply by the derivative of the inner function. Now the inner function was x to the 1/2, just in case you wanted to remind yourself of that. So the derivative of x to the 1/2 would be 1/2 x to the negative 1/2, or 1 over 2 root x. That's just basic derivative rules. So in theory, if you need to slow down and go, whoa, 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 where did that come from? That was the old school power rule. So the derivative of x to the 1/2, and I'll just do this as side work in case you're following my logic. This was 1/2 x to the negative 1/2, because that's just your regular old power rule derivative. Bring down the 1/2, subtract by 1, way old school there. And then I just cleaned it up a little bit. I brought the x to the 1/2 to the bottom and rewrote it as a square root. Now, do you have to do that? No. No, of course not. If you wrote your answer as 2 root x times 1/2 x to the negative 1/2, perfectly good. Walk away. You're done. The only reason I did it this way is so you could see if you wanted to clean it up, what you could do to clean it up. For example, I have a square root x, and then I'm dividing by square root x. In my cleaned up version of things, I don't need to have that. I can cancel those out. Just cleaning up, but seems obvious that I could do that. Same thing with this 2, and a 2 on the bottom. I could clean those up, cancel them out. So really, weirdly enough, my cleaned up answer is 1. And if you looked at the answer key and saw that the answer was 1 for this problem, it is not super obvious. When you look at the answer key and go, whoa, 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 the answer is 1, hold on, it doesn't seem like that should have happened. But once you see where each individual step of the fundamental theorem led us, it does kind of make sense why certain things ended up sort of balancing themselves out. But again, don't worry about that right now. Right now, I don't want you to look at the final result and try to make sense of that final result. Think about the steps, the individual steps, pre-cleanup, and that should help. I'll do one more series of examples to take you through a couple more tricky examples in question number 6, but I'm going to say that that next video, where I'm going to do a couple more examples, is optional. At this point, having watched this video, I think you could do everything on number 6. In fact, I think you can do everything on the entire page. So I'm going to let you make that judgment call. If at this point you feel like you've watched enough videos to get the hang of things, then I would say finish page 9 on your own. If you feel like you need a little bit more guidance, I'll select a few more questions to do videos of just as individual problems that I anticipate might give people trouble, and I'll make videos in this playlist to address those specific things. Otherwise, stop watching the videos at this point, use the answer key as your guide, and do some independent practice. Following along with the examples definitely helps, but remember the ultimate goal is that you can do these independently.